I wanted to move on to the next portion of the presentation to discuss a little bit more about a case study on the application of A3 technology to improve overall sanitation in a production environment. As Mikio mentioned, I'm Tom Boudreau. I'm the market specialist at Weber Scientific. I primarily work with breweries and wineries on improving sanitation as well as helping with their quality laboratory testing programs. I worked with one particular brewery, Great Central Brewing Company, on implementing sanitation testing with this A3 technology. They were kind enough to put together a case study on how their plant sanitation. So first and foremost, let's discuss why sanitation control is important in breweries. So unlike other common food products, alcohol in beer prevents the growth of most common pathogenic organisms, which seems like a good thing until you remember that other spoilage microorganisms are still a major concern, just like in food. So we're talking about organisms like lactic acid bacteria and wild yeast strains that can either acidify beer or produce undesirable off flavors. This is especially risky for breweries since they're also encouraging the growth of good microorganisms like the house brewer's yeast, while simultaneously trying to inhibit the growth of other organisms. This risk is compounded by the lack of pasteurization, which is unused by all but the largest breweries. Additionally, breweries include additions of raw ingredients like hops and multiple processing steps, things like carbonation, transferring between different tanks, filtration, moving to the packaging line, filling bottles. There's a broad range of critical control points where the product could be potentially contaminated. This was the case for Great Central Brewing Company. Now, they're a 100-barrel brewery, which classifies them as either a large regional brewery or a small national brewery. If you're unfamiliar with Great Central Brewing, they're a contract brewery based in the Chicago area. And if you haven't seen their beer before, it's because they're primarily contracted to fill excess capacity from other common brand name breweries. Now, this puts them at a major disadvantage because they're brewing many different types and styles of beer, which is more contamination risk. If you're using multiple ingredients, different processes, a bunch of different yeast and other microorganisms in your plant, you're going to have a harder time controlling contamination as compared to one production site where you're making a consistent product. Prior to implementing sanitation testing with the A3 system, most of testing is done using traditional microbiological techniques. We're talking things swabbing points, plating them on traditional media, and waiting to see what grows. So right away, we notice there are some major drawbacks to this. So with traditional micromedia, you're having to wait to see if organisms are actually going to grow, taking anywhere between 3 to 7 days to do this. So what do you do if you're having a new batch of beer that you just produced and you're waiting to send out to your distributor? Or what do you do if you just cleaned a piece of equipment, a tank, and you want to fill that with your next batch and you're waiting to see if it's been adequately cleaned? Now, most often, when you're using traditional microbiological techniques, you can't wait. You have to move through with your procedure. You end up accepting that risk in order to keep your production going. Now, another problem with these techniques is poor sensitivity. You can only screen so much with traditional media before you need to start either diluting your sample or limiting your testing area. And I'm sure a lot of us have seen Petri dishes that are just absolutely overgrown with all sorts of organisms that pop up from your food contact surfaces. And as soon as you start diluting or narrowing down your testing space, you risk missing those contamination organisms that might be present in your food product. And of course, traditional microtesting is just tedious. Making media, pouring plates, inoculating Petri dishes, reading and interpreting those, it's just too much work to comprehensively test your plant. So inevitably, you have to prioritize only the highest risk areas, and you missed other critical control points entirely. So when Great Central Brewing Company implementing testing with the A3 system, they had several goals in mind. First and foremost, they wanted to assess their contamination at these critical control hotspots. And because of the speed of the A3 system, they wanted to increase the total number of their testing locations. Based on the results of the A3 tests, they wanted to utilize that to make real-time sanitation and cleaning decisions with the overall goal of lowering the overall level of contamination in the plant and increasing their level of sanitation. So let's get into the meat of the study a little bit here. The quality team at Great Central Brewing chose 4 key processing points they considered high-risk hotspots. These were all taken on their canning line, their canning packaging line, and all 4 of these spots had not previously been part of their regular testing program. So these 4 test spots are a little bit difficult to explain if you're not familiar with technology, but I'll try and break them down one by one. The first test point is the can filler nozzle head. This is where the beer is actually being injected into the can while filling. The next test point was the canning bubble breaker, which is where when you have the foam after filling the cans, the bubbles are broken to allow an even fill. Then there's the undercover gasser, which is where CO2 is blown over the top of the can, eliminating oxygen and clearing out the headspace prior to the can being sealed. And finally, they tested the can line conveyor belt. Now, obviously, one of these test points, the can filler head, was a direct product contact. The 2 points afterward, the bubble breaker and the undercover gasser, were not direct product contact surfaces, but because the cans are open at this point, they are in the immediate vicinity of the product and present a contamination risk. Finally, the can line conveyor belt did not come into contact with the product, but was used as a marker for the overall sanitation of the canning line. The quality control team at Great Central took initial baseline RLU values using a Lumitester PD30 and Lucipac A3 surface swabs. They measured these test points daily over a 4-month period during normal production. During this time, the quality team amended their sanitation and cleaning protocols based on the results of the A3 system to limit contamination at these hotspots based on the readings from the A3 system. And right away, you can see the value of the A3 technology. The initial RLU values on can filler head exceeded Great Central Brewing Company's maximum allowable RLU threshold value. So immediately the quality team were able to identify a contamination point and take action. And I think if I'm remembering this correctly, they actually amended their entire can line clean and place procedure to eliminate this contamination risk. Now, it's also important to remember that these filler nozzles were not being regularly tested prior to implementing A3. So it's likely that this contamination that they examined not only would have persisted, but likely even gotten worse over time. This slide shows all of the data collected from testing with the A3 meter at the 4 test points over the 4-month period. And I know this is a lot of data to throw up, and it's probably really hard to see these results, but don't worry, I'll break them down one by one in the ensuing slides. I did want to show all of the data up at once so you can notice the trends in comparison from the full data set. And there are 2 main takeaways I want to point out here. The first is that you can see from multiple test points, there is a noticeable decrease in measured RLU values over time, indicating that with the implementation of the A3 system, Great Central Brewing was better able to control their level of plant sanitation and overall cleanliness of their canning line. The other point is that when you do see spikes in RLU values relating to the increased contamination in the line, this contamination was quickly eliminated, and sanitation was brought back under control. This is a direct result of the rapid results provided by the A3 system and the greater sensitivity, which allowed Great Central to quickly clean and check their production services before moving on to regular production. So this graph shows the test results for the can line filler head. As I mentioned, you can see the initial values from the baseline measurements exceeded the maximum allowable threshold for RLU values for a product contact surface. The quality team at Great Central Brewing determined that anything above 85 RLU was considered an action point, where the canning line production must be stopped, the canning line must be cleaned, and then retested prior to continuing production. By amending their cleaning protocols early on, this initial testing and cleaning was able to not only reduce the level of contamination, but also keep that canning line cleaner more consistently. Additionally, you can see when the contamination did occur again, and test results exceeded that recommended RLU threshold, the quality team at Great Central could rapidly clean and retest the canning line, and you can see it returned back to that acceptable RLU level. They could then be sure that any contamination had been eliminated and that they were working with a completely sanitized production line. Similarly, this graph shows the data for the undercover gasser. Now remember, this was not a direct product contact surface, but because it was directly open and exposed to the product, the quality team created a higher maximum RLU threshold where they still found some values exceeded safe levels for product contamination. Since these initial results are so high, they determined they wanted to lower the values rapidly and really refocus their cleaning system as part of the canning line process. And you can see that with the implementation of regular cleaning over time, there was a marked reduction in overall RLU readings over the 4-month period. Now we're talking at the beginning, average RLU values were right around 400, but some were peaking out at over 700. By the end of the 4-month period and the implementation of new cleaning procedures, that was brought down to an average of 40 RLU, or about a 10-fold reduction. Again, this was not an area that had been regularly tested prior to any technology and could not have been regularly tested with the techniques being used prior to implementation of this system. So this would have presented a significant risk if it had not had both the speed and the rapid sensitivity of the A3 technology. So to sum up this case study, there were 3 major improvements the Great Central Brewing Company achieved by implementing this A3 technology. First, the critical control points on the can line had a significant decrease in contamination. All 4 test points had a reduction in RLUs once they were able to detect and implement new cleaning procedures on their can line. Second, by using the A3 system, Great Central Brewing Company can now get rapid test results to confirm their level of sanitation, allowing them to both test more critical control points, as well as make real-time cleaning and production decisions that they were unable to achieve prior to the implementation of the system. And third, by implementing A3 technology, they can now be sure that they're maintaining a high level of cleanliness in the brewery, both by amending the cleaning protocols and adding the higher sensitivity to rapidly respond to the contamination threats. So I wanted to leave off with some quotes directly from the customer in their case study of using the A3 system and how effective it was for them. They reported multiple times that the brewery's plant hygiene greatly improved in a short amount of time, including the addition of that real-time, highly sensitive RLU data that the KIKKKOMAN A3 system provides. Specifically, they say one of the biggest benefits of the A3 system was that the QC team can see immediate results about contamination by observing this RLU data. They were waiting for data on swabs, referring to the traditional microbiological techniques, taking a few days. So having an accurate and reliable RLU data was a powerful tool in both speeding up the packaging process and maintaining cleanliness in the brewery. This is just one of many examples with the application of technology in lowering contamination and increasing control, not only in breweries, but other food manufacturing facilities and sanitary production facilities. And you can just see how valuable that is with the increase in the advanced technology and the benefits that it provides. So I'll now move things along for the final segment of the presentation. I'll turn it over to my colleague,